this is Prachi Sharma from SGSIT's college, and today we are going to dive into complexities of array versus linked list. First of all, what is array? Array is a linear data structure. It is a collection of homogeneous type of data. It is static in nature and has contiguous memory allocation. As we know, nodes make up linked list, or linked list is made up of nodes. For example, here is the head node. Here is the next node. In this node we have two spaces. In first we store the data. Suppose we stored here 5. We are leaving it empty right now. Here is the next node. We suppose its address is 1000. Address of this data, where the data is kept, its address is 1000. The 1000 will be stored in this. So basically this is the pointer to the next node. Here we stored the next data. Suppose we stored here 7. We had the next node over here. Its address will be stored over here. And the process goes on. Here we are provided with an array. Its size is 7. The indexing always starts with 0. 0 and goes till n minus 1. So 7 minus 1 is 6. So 1, 2, 3, 4, 5 and 6. Now suppose we are provided with some data over here. 1, 9. Suppose 10, 20, 30, 40, 50 and 70 and 80. Okay. Now we have to find the data kept at indexing number 3. So in arrays it will be easier for us. It will directly go and access the data over here and give us the real data, which is 40. Now simultaneously in linked list. Here we have nodes. Now suppose if we want to access here 7. In linked list we cannot directly access the data over here. We have to first traverse the data. We will search from here to first node, then to second node. And this will take much time. So its time complexity will be order of n. And in arrays it will take less time because it will directly access us the data. So it will take, its time complexity will be order of 1. We talked about the advantages of array, which was big O of 1, time complexity, and the disadvantages of linked list. Now let's talk the drawback of array. And suppose we are given with this array which ends in indexing 6. We have to insert just 3 elements over here. 1, 2 and 3. And this memory is left empty. So now in array this memory will be wasted and the data stored here would only be utilized. Whereas in linked list, suppose we have inserted a 6 over here and 7 over here. We need 8 to be inserted at the next node, and we do not have any present node over here. We can insert the node at the run time. Like here we have first inserted the data, now the node can be inserted. In array we cannot do the same process. So this is where we consider linked list in this case better than array, because it has compile time memory allocation and linked list has runtime memory allocation. Now let us discuss the major differences between array and linked list. First of all, resizing is expensive in array. How? Let us understand. Suppose we have fixed the size of an array as 5. We have also inserted data in it. Now if we wanted to insert more data in it, we have to change its size again, which is not really possible and will take much more time in it. Now in linked list we have dynamic size, in which even if we have made a node and inserted data in it, still we can make another node and change its size. So first difference is this. Second difference, insertion and deletion is inefficient in arrays. Why? Suppose this is an array we have. In this, we have to insert a data in this node. So first of all, data kept in this node will be shifted over here and then over here. And here the data will be inserted that we wanted to insert. In linked list, insertion and deletion is efficient. How? Suppose this is a node. We can, here we also wanted to insert another node. Suppose we have here 7, here 5. We have to insert here 6. We can directly insert a node inside this and put here 6. So this is an efficient way of insertion and deletion. memory wastage if not full. We have discussed this point earlier, but let's see this again. This is an array. If we have array of size 5, if we have inserted just 2 data over here, this 3 blocks remains empty and this memory that the block contain will be wasted, and in this no memory allocation wastage. As we know, we can insert a node after putting the data in the block, so no such memory would be wasted. Let's in fifth point, sequential access is faster. It is an element in contiguous memory allocation. If we have an array, address of the first array suppose is 1000. It will keep checking the next addresses till it gets the data, so we consider it in contiguous memory allocation. But in this linked list, we do not have data in contiguous memory allocation, so we don't have fixed addresses in it, so it will be difficult for us to find where the data is actually kept, so it will take much time than array. Let's discuss about the type of linked list. First of all, we have singly, second type is doubly, and third is circular. In circular, we also have 2 subparts. First of all, first is singly circular, second one is doubly circular. We can perform operations like insertion, deletion, create and traverse. In insertion and deletion, we do have 3 more types, like insertion at start, middle and last. And same for conclusion, we conclude that there is no specific choice between array and linked list. We can choose it up to our requirement, whichever makes our code more efficient and useful. So here we discussed in this video, the topic discussed are what is array, what is linked list, difference between array and linked list, operations we perform on linked list, and type of linked list. Thank you. Please do like, subscribe and share this video.